Question 2. Halogen alkanes are useful compounds in synthesis. Reaction pathway shown. Give the IUPAC name for this. So we know it's going to be one carbon here, another carbon, and that's a methyl group. It's going to be propane. We know that propan is going to be, well, working with, we know there's an alcohol OH on the first carbon, because CH2 bracket OH. So we've got an alcohol on the first carbon, we've got a methyl on the second carbon, and a bromo on the third carbon. So it's going to be 3 bromo, 2 methyl, because that's on the second carbon, the methyl group's on the second carbon, propan 1O, because that's where the alcohol is. Propan and alcohol is in the first carbon, so 1O. 2.2. Reaction 1 occurs via a nucleophilic substitution mechanism. Explain why the halogen alkane is attacked by nucleophile in this reaction. Now if we look at reaction 1, we know that it's to do with the carbon and the bromine, and we know bromine is more electronegative than the carbon. That's what for 1 mark. Bromine is more electronegative than the carbon. Then about the carbon, well, the carbon is partially positive. Okay, electron deficient. Carbon is partially positive, and then what actually happens is that the lone electron pair donated to partially positive carbon. Donated to the partially positive carbon. So bromine is more electronegative than the carbon. Carbon is partially positive, and the lone electron pair, or the electron pair, is donated from the nucleophile. The electron pair of the nucleophile is donated to partially positive carbon, and that will give you 3 out of 3 marks. 2.3, 2.4. 2.3 says infrared spectrum of compound Y shows significant absorption in the range this. Draw the displayed formula. I really don't like these type of questions. And that's exactly why we need to go through them. I need to go through them. So we know the IR spectrum is 1680 to 1750. So if we have a look at the data book sample, 1680 to 1750 is that. So we know it's got to have a C double bond O. So C double bond O. That's good. But we're trying to just draw the displayed form of compound Y. Well, we know compound Y is C4H6O2. C4H6O2. And so now if we draw it out, 3 carbons, we also know from this that there's a methyl group on the second carbon. Yeah, a methyl group on the second carbon. So we're gonna have CHHH. Now because it's O2, CO2, we're gonna have these times by 2. So we're gonna have C double bond O H H C double bond O H, and then to make sure you're correct, add up the number of carbons. 1, 2, 3, 4. C4. How many hydrogens? 1, 2, 3, 4, 5, 6. H6. How many oxygens? O2. and we've used the C double bond O from the IR spectrum wave number bond. That's that for 1 mark. For these type of questions, you just need to, it's like any type of question really, but you do need to expose yourself to these types, because it's really hard in exam. You're like, 1 mark, what do I do? But you need to read the question properly, look at the infrared spectrum, look at the actual formula of the compound, and then realize, okay, it's O2, so we're gonna have 2 double bond O, and we know it's C double bond O because of the wave number. Okay, and then I just draw it out like that. And I also know it has a methyl group because from the beginning it's got a methyl group on the second carbon. And then 2.4, compound Z has an empirical formula C3H4NO. Give the structure of compound Z. C3H4NO. Well, that's the empirical formula. We know the empirical formula of compound Y is C2H3O. We just divided everything by 2. So how do we get from here to here? Well, we're gonna add a carbon, we're gonna add a hydrogen, and we're gonna add a nitrogen. So what is going on is that, remember, hydroxynitrile is a molecule containing CN and ON and OH group. So it's going to be a hydroxynitrile. So the structure of compound Z